Today we will start exercise 11.3. As we have seen all the examples on this exercise, we should do the exercise problems. First problem. Given f of x equal to kx into e power minus 2x for x greater than 0, 0 otherwise is a PDF. Find k, this is the question. So they give this function as a probability density function, and I have to find out this k. The function is a probability density function. We know the total integration is 1 because sum of all the probability is 1, therefore total integration is 1. So given f of x is a PDF, then this implies integral minus infinity to plus infinity f of x dx equal to 1. Now the function is existing only for greater than 0. That means I can write this one as minus infinity to 0 f of x dx plus 0 to infinity f of x dx. This is equal to 1 because it is having a split at 0. Now from minus infinity to 0, this one it is 0. Therefore, I can write the first integration as 0. Second one is 0 to infinity. 0 to infinity. F of x value is kx into e power minus 2x dx. This is equal to 1. So this is k into 0 to infinity x into e power minus 2x dx. This is equal to 1. Now we shall keep this one as 1. Now this is of the form integral 0 to infinity x power n into e power minus ax dx. This form is called particular case. By particular case of gamma integral, we can write this one as n factorial by a power n plus 1. The result of this one is, if it is on the form x power n into e power minus ax, then it is n factorial by a power n plus 1, where n is the power of x, where a is the number which is coming with in the e power minus x. Therefore, when I compare this x power 1, so here n equal to 1, e power minus 2x, e power minus ax. So in the place of a we have plus 2. Therefore 1 becomes k into n factorial means 1 factorial by a means 2 power 1 plus 1. This is equal to 1. So k into 1 by 2 square is 1. Therefore, k equal to 2 square is 4, cross multiplying k equal to 4. This is the answer of the first problem. So, here they apply the particular case of gamma integral. We will be studying in our integration chapter. So, x power n into e power minus ax means it is n factorial by a power n plus 1 straightly. After integrating and after applying all the limits, the answer will be of this format. So, this is your first problem. Now we shall go to the second one. Given f of x is a PDF such that f of x equal to x when it is 0 less than x less than 1, 2 minus x for 1 less than or equal to x less than 2, and then 0 otherwise. Now I have to find first question p of 0.2 less than or equal to x less than or equal to 0.6. Second question p of 1.2 less than or equal to x less than 1.8. Then we have third question also, p of 0.5 less than or equal to x less than 1.5. So 3 values I have to find out. They gave it is a PDF. So I have to find out the probability means I have to integrate, that's all. So first question, P of 0.2 less than or equal to x less than or equal to 0.6 means I have to integrate from 0.2 to 0.6. 0.2 to 0.6 means it is up to 1 only. So it lies only in this interval. For that interval x value, the f of x value is x into dx. Therefore, first question, p of 0.2 less than x less than 0.6 or less than or equal to. Here it is continuous distribution, so less than or equal to, both are considered to be the same. Therefore, it is, when I go for integration straightly, x for integration is x square by 2 and the limits are 0.2 to 0.6. When I apply this is 0.36 by 2 minus 0.04 by 2. It is 0.36 minus 0.4 is 0.32 by 0.2. So the answer is 0.16. This is the first value. Now, second one. P of 1.2 less than x less than 1.8. I have to find out the integration from 0.1 to 1.2 to 1.8. Since it is more than 2 and less than, more than 1 and less than 2, I must take this value. That value is 2 minus x into dx. Now, integrating this. Can you understand? For 0.2 to 0.6, the whole value is less than 1, so I took the first value. Because there, x is the value between 0 and 1. Now it is 1.2 to 1.6, so more than 2. So I must take 2 minus x. Integration of 2 minus x is 2 integration is 2x minus x integration is x square by 2. And limits are 1.2 to 1.8. We shall simplify this. This is, when I apply the upper limit, 2 into 1.8 is 3.6 minus 1.8 the whole square, isn't it? 1.8 the whole square is 3.24. 324. 3.24 by 2. This is upper limit. Minus lower limit is 2x are 2 12s. 2 12s are 24, so it is 2.4. Minus 12 square is 144, so 1.44 by 2. So it is 3.6 minus 1.62. Right? 1.62 minus 2.4 minus it is 0.72. Now we shall subtract this. 3.6, 1.62, 10 minus 8, 10 minus 2, 8, here 5, 15 minus 6, 9, 2 minus 1, 1, 1.98 minus 2.4, 0.72. 10 minus 2, 8, here 13, 6, 1.68. So the answer is 0.3. This is the value. Now we will go for third question. P of 0.5 less than or equal to less than 1.5. The function is existing up to 2 one value and then up to 2 one value and after 2 another value. So I can split the interval as 0.5 to 1 f of x dx plus 1 to 1.5 f of x dx. Therefore, up to 1 there is a value and after 1 there is another value, isn't it? So 0.5 to 1 f of x value is simply x. And 1 to 1.5, that is after 1 the value is 2 minus x into dx. Here x integration is x square by 2 and for that a separate limit is 0.5 to 1. And this we know 2 integration is 2x minus x integration is x square by 2. It is 1 to 1.5. So simplify this one separately. It is 1 by 2 minus 0.5 the whole square is 25, that is 0.25 by 2. Plus. When I multiply with 1.5 it is 3.0 minus 2.25 by 2. This is upper limit minus lower limit is 2 minus 1 by 2. We should simplify all this now. It is 1 by 2. 1 minus 0.25 is 0.75 by 2. This is the first bracket. Now, 15. Therefore 2 3s are 6, 6.00, 2.25. 5, 9 minus 2, 7 is 5 minus 2, 3, 3.75 by 2 minus 4 minus 1, 3 by 2. So the answer is 0.75 by 2 plus 3.75 minus 3 is 0.75 by 2. Is it not 2 into 0.75 by 2? So 2 cancels, it is 0.75. So this is the answer of the second problem. So according to the limits, we must know how to split the function, and after that we have to integrate. Okay, after integrating, upper limit minus lower limit we have to substitute. With that, second problem is over. Now given, we should go for the third problem. Given PDF, f of x is k, which is existing only from 200 to 600, 0 otherwise. They are asking us to find out the value of k, the distribution function, and also this probability. Okay. Given, so first we shall find k. Given f of x is a PDF, then this implies total integration from minus infinity to plus infinity. F of x dx is 1, that is minus infinity to 200 f of x dx plus 200 to 600 f of x dx, then from 600 to infinity f of x dx. All these three are giving me the value 1. But this doesn't exist because the function exists only from 200 to 600 and 0 for all the others. So this is also 0. And 200 to 600, it is k into dx. And then this is also 0, which is 1. Now, only this integration is existing. So k can be taken out. 200 to 600 dx. This is equal to 1. Then dx integration is x. 200 to 600, then k equal to 1. K into upper limit is 600 minus 200 equal to 1. This is 400, when it is taken to the other side, 1 by 400. This is the value of k. So I found the first question. Second one, I have to find out the distribution function. Distribution function, first one is when x is less than 200, that is capital F of x is from minus infinity to 200 f of x dx. But the function does not existing before 200, therefore the value is 0 straightly. Now in this one, when x belongs to between 200 and 600, capital F of x is, it is not that I have to find out only from 200 to 600, I have to add from minus infinity to 200 f of x dx, and I need the function, so it is from 200 to x. So better write f of t dt. We know this is not existing, and 200 to x, f of x is k, so f of t is also k into dt. It is k can be taken out. dt integration is t and the limits are 200 to x. We know k value is 1 by 400. Upper limit is x, lower limit is 200. So the value is x minus 200 by 400. Now I will write it down. Still it is not over. I have taken only less than 200 and 200 to 600. Now we have to consider for more than 600. That is, when x belongs to 600 to infinity, then capital F of x is, I have to add from minus infinity to 200 f of x dx. Then 200 to 600, it is f of x dx. Then 600 to infinity, instead of infinity I must put x because I have to find out the function. Then it is f of t dt. But these values are not existing, isn't it? So this is 0 and this is 200 to 600. This is k into dx. And after 600 also the function is not existing, so it is 0. K into integration of dx is x. 200 to 600. So K value is 1 by 400 into 600 minus 200. So it is 400 by 400. So answer is 1. Therefore, what is the distribution function? Capital F of x is, first value is, distribution function is 0 for minus infinity less than x less than 200. Then it is x minus 200 by 400 for 200 less than x less than 600. Then it is always 1 the final value for 600 less than x less than infinity. This is the distribution function. Now they are asking the third question, a probability. Third question is P of 300 less than x less than 600. Here may be less than or equal to whatever it is. Less than or equal to, no need to worry because it is continuous distribution. So it is 300 to 600. But the value is k dx only, all the remaining are not existing. So k can be taken out, dx integration is x. 300 to 600. We know k value is 1 by 400 and it is 600 minus 300. So it is 300 by 400. So answer is 3 by 4. 3 by 4 means it is 0.75. Result, this question is over. Now we shall pass on to next question, fourth question. Given PDF f of x equal to k into e power minus x by 3 for x greater than 0 and 0 for x less than or equal to 0. Find. There are too many questions. Find k. Second question, distribution function. Then third question, P of x less than 3. And fourth question, P of x 5 less than or equal to x. And then fifth question, P of x less than or equal to 4. For this problem alone, we are going to find out the probability in a different way. So all the remainings are as usual. So first to find k. We have to find out k. Given f of x is k into e power minus x by 3 for x greater than 0 and 0 for otherwise. And I have to find out all this thing. First we shall find k. Given f of x is a period, then this implies from minus infinity to plus infinity, f of x dx is 1. I can write this one as minus infinity to 0 f of x dx and then from 0 to infinity f of x dx, because we know the function is having two splits, one from 0 to others and the other one is up to 0. Up to 0 the value is 0, then from 0 to infinity k into e power minus x by 3 dx, this is equal to 1. Now let me do it here itself. It is k can be taken out. 0 to infinity e power minus x by 3 dx equal to 1. E power x integration is e power x. E power integration with some coefficient x means that coefficient must divide the answer. That is k into e power minus x by 3. The coefficient of x by x is minus 1 by 3. So that will divide the answer. 0 to infinity, this is equal to 1. Now if I take that way, it is minus 3k. E power minus x by 3, 0 to infinity, this is equal to 1. Shall I write this one as minus 3k into 1 by e power x by 3, 0 to infinity, this is equal to 1. So it is minus 3k. When I apply it is 1 by e power infinity minus 1 by e power 0. This is equal to 1. minus 3k, it is 1 by infinity minus 1 by 1 equal to e power infinity is infinity minus 3k, 1 by infinity is 0 minus 1 equal to e power 0 is 1. So it is multiply 3k equal to 1, k equal to 1 by 3. So this is the function we have where k value is 1 by 3. Now let me go for distribution function. Function k value e f of x is k into e power x minus 3. Second question. Distribution function, that is capital F of x. It is not that I have to find out the function, I have to add then and there the previous functions too. That is, first when x belongs to less than 0, then capital F of x is minus infinity to f of 0 f of x dx. But the function does not exist from minus into 0, so it is minus into 0, 0 into dx, so it is 0. Now, I have to find out when x is greater than 0. Here capital F of x means I have to consider from minus infinity to 0 f of x dx plus 0 to x f of t dt. Now this is 0 to x. F of x is given as k into e power minus x by 3. So it is k into e power minus t by 3 dt. Now that is equal to k can be taken out. E power minus t by 3 integration is e power minus t by 3 by minus 1 by 3 and limits are 0 dx. As usual when it goes, it is minus 3k. It is 1 by e power t by 3, 0 to x. To avoid the negative power, we know k value is 1 by 3 into 1 by e power x by 3 minus 1 by e power 0. It is minus 1. 1 by, we can write as e power minus x by 3 minus 1. When I take the minus 1 inside, this will become positive. So 1 minus e power minus x by 3. So this takes till infinity itself. So that's all about distribution function. So f of x is 0 for minus infinity less than x less than 0 and 1 minus e power minus x by 3 for 0 less than x less than infinity. This is the second answer. Now we shall go for the remaining things. Since I am having distribution function, we can go for the remaining properties using capital F of x. Listen here. First one, p of x less than 0 means p of x less than or equal to 3 also. We know capital F of x is p of x less than or equal to small x. Then it is less than or equal to 3 means it is f of 3. F of 3 means substitute x as 3, 1 minus e power minus 3 by 3. It is 1 minus e power minus 1 or 1 minus 1 by e. So it is e minus 1 by e. Or you can stop up to this 1 minus e power minus 1 or 1 minus 1 by e. Then fourth question. P of phi less than or equal to x, meaning p of x greater than or equal to phi. Shall I write this one as 1 minus p of x less than phi? Means 1 minus f of phi. 1 minus f of phi is 1 minus e power minus phi by 3. I can put x as phi. When I take inside 1 minus 1 cancel, this also positive e power minus phi by 3. Similarly, final question. P of x less than or equal to 4 means f of 4. F of 4 is 1 minus e power minus 4 by 3. So when you have the probability and if you are very known about less than or equal to or greater than or equal to, we can apply the distribution function value itself to find out the probabilities. So with that, Problem number 4 is over. Next we shall go to problem number 5. Now fifth problem. Given PDF f of x equal to x plus 1 for minus 1 less than or equal to x less than 0, minus x plus 1, 0 less than or equal to x less than 1, 0 otherwise. Just two questions. Find first question, distribution function capital F of x, and then second question, p of minus 0.5 less than or equal to x less than or equal to 0.5. Okay, the intervals are spread like this from minus 1 to 0 1 value, then 0 to 1 1 value, and 0 for all the remaining values. So first we should straightly go for distribution function. I must find up to minus 1, then minus 1 to 0, then minus 0, minus 1 to 1, then minus 1 to infinity. I have to add up everything. That is capital F of x. First one, when x is belongs to minus infinity to minus 1. F of x is integral minus infinity to minus 1, f of x dx, but that one is not existing, so 0. Now second interval, when x belongs to, it gets split from minus 1 to 0. Then capital F of x is, remember, minus infinity to minus 1 f of x dx. Then I need the function, so it is minus 1 to x, f of t dt. Now substitute f of x equal to, this one is 0, then minus 1 to x, minus 1 to x in this value, here it is x plus 1, in terms of t, t plus 1 into dt. So it is, t integration is t squared by 2, 1 integration with respect to t, and limits are minus 1 to x. When we apply the upper limit, it is x squared by 2 plus x minus lower limit plus 1 by 2 minus 1. It is x square. Anyhow, we are going to write in terms of denominator 2x square plus 2x by 2 minus half minus means minus half. So it is x square plus 2x plus 1 whole divided by 2. Is it not our x plus 1 the whole square by 2? This is from minus 1 to 0. Now, I need third one, when x belongs to 0 to 1. That means capital F of x is, remember, it is minus infinity to minus 1, 1 f of x dx. Then from minus 1 to 0, another f of x dx. Then from 0 to x, not 1. And last integration always it must be f of t dt. Now this is not existing, so 0. Minus 1 to 0, this value is x plus 1 into dx, whereas this value is minus x plus 1 for x, if it is in t means minus t plus 1 into dt. So we can omit this 0, x integration is x squared by 2, 1 integration 1 into dx is x. Here the limits are 1, minus 1 to 0. Whereas here the integration is minus t squared by 2 plus t. Limits are 0 to x. When I apply 0, everything becomes 0. Minus. When I apply minus 1, it is plus 1 by 2 minus 1. Plus. When we apply x, it is minus x squared by 2 plus x. Lower limit is everything 0. It is minus 1 by 2, so plus 1 by 2. Minus x squared by 2 plus x, isn't it? Now when I take LCM as 2, 1 minus x squared plus 2x. 1 minus x squared plus 2x. This is 0 to 1. Then finally, one more thing you have to find out. That is third one, when x belongs to 1 to infinity, then f of x is, remember, minus infinity to minus 1 f of x dx. plus minus 1 to 0 f of x dx. Then 0 to 1 f of x dx. Then 1 to instead of infinity x, in the last interval iteration must be always f of t dt. Now, this is not existing, so 0. This is minus 1 to 0. We know it is x plus 1 into dx. And this also we know 0 to 1 f of x is minus x plus 1 into dx. And this is not existing afterwards, so this is 0. And this value we found here only, so the value is plus 1 by 2. So shall we write this value as 1 by 2? Remember, x plus 1 and same limit, x square by 2 plus x. So 0 minus 1 by 2 minus 1, so it is 1 by 2. That 1 by 2 is the name. So always, it's better to iterate 1 by 2. This is minus x square by 2 plus x. And the limits are 0 to 1. It is 1 by 2. When I apply upper limit, minus 1 by 2 plus 1. And the lower limit is 0. It is 1 by 2 minus 1 by 2 plus 1. 1 by 2 cancels 1. So with this, I can write the distribution function. What is the distribution function? Therefore, distribution function f of x equal to first one 0 for minus infinity less than x less than minus 1. Then up to minus 1 we have x plus 1 the whole square by 2. Minus 1 less than x less than 0. Then from 0 to 1, 1 minus x square plus 2x by 2. 0 less than x less than 1. And then final value always 1 for 1 less than x less than infinity. This is the distribution function. Now we should go for second question. Probability of 0.5 less than or equal to x less than or equal to minus 0.5 to 0.5. Is it minus 0.5 to 0.5 f of x dx? But the value is only from minus 1 to 0. So it is minus 0.5 to 0 f of x dx. Then 0 to 0.5 f of x dx. Minus 1 to 0, this will take this value. 0 to 0.5, this will be taken by that value. That is probability, not this is distribution function. Minus 0.5 to 0. F of x is x plus 1, isn't it? X plus 1 into dx. Whereas 0 to 0.5 it is minus x plus 1 into dx. So integrate now. Here x square by 2 plus x. Limits are minus 0.5 to 0. Here it is minus x square by 2 plus x. 0 to 0.5. When I apply the upper limit, it becomes 0. Lower limit is minus 0.5 whole square is 25. That is 0.25 by 2 minus 0.5. And x square is 25 means 0.25. The whole square is minus 0.5. Similarly, this is minus 0.25 by 2 plus 0.5. So we remove all the brackets. Minus 0.25 by 2. Minus into minus plus 0.5. Minus 0.25 by 2 plus 0.5. I can add these two. Minus 0.50 by 2. 0.5 is 1. It is minus 0.25 plus 1. Answer is 0.75. So this is the answer of problem number 5. And we are having next problem, problem number 6. Shall do problem number 6 now. Given distribution function capital F of x equal to 0 for x less than 0. 1 by 2 into x square plus x for 0 less than or equal to x less than 1 and 1 x greater than or equal to 1. Now we are asking the reverse form. Find the PDF. Then second question, probability of 0.3 less than or equal to x less than or equal to 0.6. Now we can go by the usual method. Remember, distribution function is defined by interface mark f of x dx. So when I differentiate capital F of x, I will get small f of x. So we know that interface small f of PDF f dash f of x is capital F dash of x. When I differentiate capital F dash of x, I will get small f of x. So straightly small f of x equal to differentiate capital F of x. 0 differentiation is 0 for x less than 0. This is 1 by 2 into 2x plus 1. 0 less than or equal to x less than 1. X square differentiation is 2x, x differentiation is 1. 1 differentiation is 0 for x greater than or equal to 1. That means I can conclude small f of x as, shall I write here itself? Small f of x as 1 by 2 into 2x plus 1 for 0 less than or equal to x less than 1. 0 otherwise. So this is small. Now second question, I have to find out the probability of 0.3 less than or equal to x less than or equal to 0.6. Means I have to integrate from 0.3 to 0.6 f of x dx. So it is 0.3 to 0.6. F of x is this one. 1 by 2 into 2x plus 1 into dx. 1 by 2 can be taken out. 2x integration is 2x square by 2 plus 1 into dx integration is x. It is 0.3 to 0.6. 1 by 2. Here 2 cancels, x square plus x. 0.3 to 0.6. It is 1 by 2 into, when I apply upper limit, 0.36 plus 0.6 minus 0.09 plus 0.3. While adding, try to add seriously, that is, it is 0.36 and then 0.6. So the answer is 0.96 minus 0.09, 0.3, it is 0.39. So 0.96 minus 0.39, 16 minus 9, 7, then it is 8 minus 3, 5. It is 0.57 by 2. When we divide by 0.3, it is 0.2 times, remainder 17. 8 times 16, remainder 0.285. So this is the answer. So with that, exercise 11.3 is over. Now we shall see in exercise 11.4. Thank you.